this little video is to explain the idea of buffers, and we need equilibrium to do so. So let's start with the definition, which must be able to restate back. So it's a solution that contains similar amounts of a weak acid with its conjugate base, and as a consequence, because it's an equilibrium reaction, it resists pH change. So we're not introducing any new work, but we're using Le Chatelier's principle to explain why buffers are able to resist pH change. And they're very important to a number of systems, including living systems. This particular buffer, now presumably, if we go back one, but if I said that the acid that would come to mind, first off would be acetic acid, because we know that the carbon acids are all weak acids, and it, combined with its conjugate base, is indeed a buffer system that would resist pH. But I'm going to choose one that has more relevance in a number of systems, living and non-living, to explain further. And it's another weak acid, carbonic acid, with its conjugate base, the hydrogen carbonate ion, because it has such relevance in the natural world and in the living world. So let's write ourselves an equation to show that. So we've got carbonic acid plus water. Now as an acid, it's going to donate its hydrogen ion across here, as acids are proton donors using the Lowry-Bronsted idea, and the other product will be the hydronium ion. We know that's an equilibrium process, and that's the key to explaining why it's able to resist pH change. Now, pH is linked to this idea here. We know that pH is the acidity. Acidity is a measure of the hydrogen ion concentration, or another way of saying the hydrogen ion concentration is the hydronium ion concentration. So this is the bit we're looking at. So, okay, we're talking about resisting change. So let's say our change is that we increase the amount of hydronium ion. Or we could say that would be the same as lower the pH. Now, in this system, what happens is we know Le Chatelier kicks in. Our response will be the opposite. You've tried to lower, we're going to lower, increase the hydrogen ion concentration. The response would be to get that hydrogen ion concentration to go down again. And it will do that by sliding this way in this equation, because we are going to use up the things on the right to make the things on the left. And we've actually then achieved what we said we'd achieve. We've tried to change the pH, and the systems stop that happening by Le Chatelier sliding the extra hydrogen ions. So we've done this, we've added extra of the hydrogen ions in. Le Chatelier's kicked in because we've disturbed this equilibrium reaction, and it's responded by moving some this way to undo the change, and hence the hydrogen ion concentration of the pH has remained unchanged. And this is very important to our bodies specifically, because enzymes are designed to work at a certain pH, and this is ensuring that our body stays at that pH so everything works well. Thank you for listening.